Hello everyone, Simon here. In today's premium or member only video, what I'm going to show you, I want to expand a little bit more on the free enhanced course that I released. And in this video, we will dive deep into how you can squeeze out a little bit more performance out of your enhanced servers, and also how to make your hosting environments for the websites more secure. So what we will cover are the Linux server optimizations. Then we will cover the php.ini directives with some disable functions, and also I will touch on how you can optimize your MariaDB database for the best performance for the specific server type what you have. And then also I will talk just a little bit about the Redis object caching and how you can make it more secure, because by default it is not secure, and there is some variable that we need to add to make it secure basically. So yeah, that's it for today's video for you as Webnestify channel members, and I wanted to also seriously thank you for your support, and yeah, stay tuned for the next premium video, and yeah, give it a like, and if you have any questions, feel free to join the Webnestify Discord, where you have also access to VIP channel with all the resources, because I will be also linking all the variables and everything what I will show you and explain piece by piece. Everything will be nicely set in the document, so we can just copy and paste. So yeah, let's get right into it. Okay, so the first part will be optimizing your server. So these tweaks will help your server handle storage and memory operations more efficiently. They are small changes that can seriously make a big difference in performance, especially for hosting workloads. And so the first tweak what we will going to add is no at time flag to our system disk. And let me explain what it does. So by default, the Linux updates the last accessed timestamp called a time every time a file is read, even if it's not modified. That means for every read operation, your disk performs an additional write, and this is unnecessary and wasteful, especially on SSDs. So the no at time option stops Linux from updating the timestamps, so it doesn't write to disk every time you or your application simply read a file. So in order to add that no at time flag to your fstab, you need to edit it. So let's just open it. So do nano etc fstab, and make sure to find your primary partition, which is usually ext4. And what we want to do here behind the defaults, we just add no at time and another colon, and that's it. We just Control O, enter to confirm, and Control X to exit. And now we instruct disk to stop updating the timestamps. And yeah, as I was mentioning, the benefits are fewer disk writes, better performance, lower SSD wear, and slightly faster read times. And the trade-off can be you will lose the last access information for files, but most systems and applications don't rely on it. Second optimization, what we add is to avoid using swap whenever possible. So swap is a portion of disk space used when your system runs out of RAM, but the disks are much slower than memory, so once your system starts swapping, the performance drops drastically. And to minimize this, we can also instruct the kernel to avoid swap until it's absolutely necessary. And in order to do it, we will need to add this tweak to our system control config file. So do nano /etc /system control.conf, and just scroll at the end of this file and just add the following vm.swappiness equals to 0. And then also the third option, the third optimization trick, we can also optimize the disk write behavior. That means when your system modifies the data, it doesn't always write immediately to the disk. Instead, it caches data in memory and writes it in a larger batches. So this is faster, but introduces a smaller risk if your system crashes before flushing the data. And we can tune how aggressive this caching is with the following two parameters. So first one is vm.dirty underscore ratio equals, and in my case I like to use a ratio of 15, and another directive that we add is vm.dirty background ratio, and I usually put this to 5. So let me explain what vm.dirty ratio is. This is the maximum percentage of system memory that can be filled with dirty or unwritten data before it's forced to write to disk. And what is the VM dirty background ratio? This is when the threshold is reached, the background processes start writing cache data to disk quietly. So yeah, what are the benefits of this? So you will have fewer, larger write operations, mean better performance. And this is especially effective for servers handling a lot of small files. And what are the trade-offs? Slightly higher risk of data loss if power or kernel crashes before data is flashed to the disk. But most of the servers we have in the data centers are on stable power, so this is a reasonable optimization. And once you have those three optimization written, just Ctrl O and enter and Ctrl X to exit. And now you will need to type system Ctrl P to kernel take advantage of these new directives. Okay, like that. And as you can see, we have also output what we actually put. Another thing that I wanted to show you is how you can disable the swap space on your disk. So most of the time when you deploy your server or you have my cloud init config, I usually put 4 GB swap file on every single server. And you can verify the swap file going also by the htop, and you will see the swap here, the metrics, and you will see 4G, like the 4 gigabytes. In my case, I already have disabled it, but I'm going to show you step by step how we can do it. So let's just repeat what the swap space on your server is. So swap is a space on your disk that Linux uses as extra memory when your system memory is full. While it can prevent out-of-memory errors, it will slow your system down significantly because disk access is much slower than RAM. So for performance-focused hosting environments like dedicated enhanced setups, it's often better to minimize it or completely disable swap as long as your server has enough of physical RAM. But here comes a disclaimer. For example, if you have a 2 GB server or 4 GB server, do not disable the swap space because you will get too many memory out of memory issues. And if you have 8 GB or more, I believe you can freely disable the swap space. So how we can actually do it? So first you will need to type swap of 1p, and this will disable the swap. Then we will need to go to our etc fstab, so nano etc fstab, and here you will have also the volume for the swap file, and usually it will be shown as like this. You will have your swap file here, and what you need to do is just to remove this entry from mounting the system reboots. In order to do it, just do Ctrl K and then also exit out of it. So now we have also disabled the mounting of the swap file. And then also when you navigate to the root folder, when you do ls-al, you will also see the 4 GB swap file here because we did not remove it. And in order to remove that, all you need to type is rm swap file. And we cannot remove the swap file because we already do it. So in this case, you will need to type this and the swap file will be disabled. And yeah, that's basically it for the Linux server optimization. And now let's move into the PHP optimization. Okay, and now let's go over the PHP directives and those that I recommend on every single enhanced instance. You might find when you look at the PHP documentation there are way more PHP directives you can use, but those that I'm going to show you I think are staple for any hosting environment. Okay, so let's begin. So first what we need to go is go to the settings, service, application, and here we can put our PHP.ini directives that will take effect on every single website that you deploy on your enhance. So first let's add our first directive, and that is pretty straightforward. It is date.timezone. And this directive basically tells PHP what default time zone to use for date and time function. Sometimes the WordPress instance does not take exactly from the server if you set up the time zone, or if you forget to set the proper time zone on your server side. So this will tell the proper time zone you are in. So in my case it is Europe, Bratislava. And your time zone may vary, so you may put your time zone that you are in. So let's click create. Another directive that I like to use as default is PHP Docker, socket timeout. And this sets how long PHP will wait in seconds for socket-based connections to respond, like when PHP connects to an external service of databases. So this is really a helpful directive to have if your PHP is connecting somewhere else from your WordPress website. So how to set this timeout is pretty simple. You just type default socket timeout, and there is some standard that I like to use. It really depends on the web application, but I like to use like 90 seconds for this timeout to occur. So if you know that you're going to have some external collections or something like that, just start with 90 and then test. If the script fails or something like that, you will need to most likely increase this socket timeout. So let's just do 90. Another directives that we are going to add is disable function, and this is seriously crucial. So the disable function directive in the php.ini is one of the most important layers of PHP hardening. It prevents certain built-in functions from being executed or being used, especially those that could execute system commands, manipulate user permissions, or expose sensitive information if your site were ever compromised. So let's go through them one by one. So first directives, what are we going to disable are system command execution function. And these allow PHP to run commands directly on the server's operating system. So it is extremely dangerous if abused. So let me copy those directives that are part of the system command execution functions. As you can see, we have exec, system, pass-through, shell exec, popen, and all of those. And yeah, those can run shell commands or open system processes. So if an attacker injects code through a vulnerable plugin or form, this could give them full access. Another Another group that we want to disable are dynamic linking and source viewing. So let's go back here and let's just type DL. And this function dynamically loads PHP extension at runtime. Not needed seriously in modern environments and can be exploited to load malicious extension. And then another is show underscore source. And this will output the raw source code of an PHP file. And this is dangerous because it could reveal the sensitive credentials or logic to an attacker. And the third group that I like to disable all the time are POSIX, so-called process control functions. And these deal with Unix level processes and user management. Very low level and rarely needed for the web application. So let me copy those and let me paste at the end. And as you can see, there are a lot functions in these groups. So you can find the document, also the link in the Discord for the premium members. And these permissions or functions can change process owners, modify privileges, or get sensitive system information. And disabling them helps prevent privilege escalation, attacks, and system tampering. And that's it for those disabled functions. So these functions are seriously powerful and can be dangerous. And most web applications, including WordPress, Laravel, and others, don't need them or they don't rely on them. So by disabling those, you significantly reduce the attack surface of your PHP environment. And if you are going to use, for example, the WordPress CLI, and you want to dump databases or execute some scripts that you might build, you might want to remove this exec function. Otherwise, it will be blocked from the website container. So make sure you disable it, and when you are finished, just enable it again to be on the safe side. And yeah, let's continue with another PHP directives. And those, this is will be basically max execution time. So max execution underscore time. And this sets the maximum time in seconds a PHP script can run before it's automatically stopped. And this could help prevent buggy or malicious script from overloading the server. And yeah, I usually put this to 60 seconds. And if you need more time for your scripts, you can change it here. So let's create. Another directive is max input time, max underscore input time. And this defines how long PHP will spend parsing the input data, like post or get request. So usually rule of thumb is to keeping this value close to the max execution time, which is good practice for consistency. And again, this is also beneficial if you are receiving data to your web application from some webhooks or some script, or you are sending data outside. So yeah, let's put it to the 60 seconds. Another directive is max input vars. And this limits the number of variables PHP will accept from a form submission. And this is useful for preventing denial of service attacks through massive form submissions while still supporting the large admin panels like WordPress, Elementors, etc., etc. And if you are using Metabox or some advanced custom fields or WP Grid Builder, you will notice that they require it to have at least max input vars to 3000. So in our case, I like to put it to 4000, and I never got into any issues. Okay, another important directive is memory limit. And this sets how much memory PHP script are allowed to use. So depending on your server and the specs, like if you have 8 gigabytes or more system memory. I like to use like 128 megabytes. And in some cases, if it's seriously like big WooCommerce website, you can play with 256 or 512 megabytes of PHP memory limit. But note, if you have 20 websites with 128 memory, those websites can potentially just use almost 2 gigabytes just for the PHP. So you need to also tweak this accordingly. So you need to know your websites, you need to know your server. Otherwise, you can have some timeout issues. But I think 128 megabytes is seriously good enough because many share hosting providers don't use 128 megabytes. So let's click create. And then we will add also a post max size. And this is self-explanatory. It will limit or control the maximum size of post request, which usually affects file uploads and form submission. And yeah, I like to use like 32 megabytes because yeah, we don't need any posts larger, like 32 megabytes. Let's click create. And another directive is upload max size. And this will tells PHP and defines the largest file size users can upload. So if clients upload the big media files, you can increase this. And also make sure your web server like Nginx Apache allows the same or larger upload size. And by default, Lightspeed and OpenLightspeed, they don't limit the upload file max size. And this is really handy. For example, if you have customers that are uploading images, unoptimized images within the 10 megabytes or 20 megabytes files, and then they are complaining about the disk space. So yeah, just limit upload max file size accordingly. And in my case, I always put like 2 megabytes of upload max size because yeah, you should be uploading images that are already somehow optimized. Otherwise, you will spend the disk space very, very quickly. Or you can even put it to the post max size. That's completely up to you. So yeah, we can do 32 megabytes. But if you want to limit your customers with the file size, this is the directive to control it. Let's click create. And yeah, that's it for those directives. And yeah, in the PHP documentation, you can find way more that you could possibly use. But I think those are this is like the standard blueprint for what I'm using also in my business. So those directives are tested, and yeah, there is no issue with them. And now let's move how we can optimize our Maria database. Okay, so now it's time to take care of our MariaDB database application. So in order to edit or tweak your MariaDB, you need to open your web application server, go to databases, and here you can see my.cnf configuration file. And this tool allows you to customize the primary configuration for your database server. So let's edit our configuration. And here I'm going to paste some things that I have on my production servers. And I will walk you through step by step why I put those there and what exactly to explain to you what it does. So first, what I wanted to comment is innodb flash log at trx commit 0. So this controls how often innodb writes transaction logs to the disk. So if you put a value 1, that means it will flash to disk every transaction. It is the safest but the slowest option. And if you set it 0, like I did, it will write logs in batches and flashing less often, which make it overall faster. And the benefit is it will greatly improve the write performance. Downside is you can lose a few seconds of data in case of a power failure or crash. So in our cases, we don't need to worry about the power failures or crashes because our systems are stable and the server is hosted on the stable infrastructure. Another innodb file per table. That means it will store each table and its indexes in a separate .ibd file instead of one huge shared file. So benefit is it will easier backups, smaller recovery scope, more efficient table maintenance. There is also downside, which will it will write slightly more files on the disk, but negligible on our modern systems. So let me remove that. Okay, I'm gonna put it back. So yeah, and this is recommended for every modern setup. Then we have innodb thread concurrency to 0. And this means it will let innodb automatically decide how many threads it can run in parallel. So the benefit is that it will auto-tune the concurrency based on workload and the CPU cores. So on this server we have 2 CPU cores, so you can even put 2 to use all available 2 CPU cores. But if you scale your server, to 4 CPU core or 8 CPU core and you forget to change it, you will lose the performance. So keep it at 0 and it will automatically adjust depending on the hardware that it has. So keep it at 0 and basically it will auto scale with the server. Then we have innodb buffer pool size. I set it to 2 GB, and this is the most critical memory parameter. So the buffer pool stores table data and indexes in memory for fast access. So the benefit is the larger buffer equals to fewer disk reads and faster queries. And downside is setting it too high can starve operating system and cause swapping. And I explained swapping already, what it means. And so guideline is to use 50 to 70% of total system RAM, but never more than 20% of the server runs multiple services like website and database. So yeah, what I recommend, the minimum is like 215 megabytes for small servers, but we have 8 gigabytes of system memory, so yeah, 2 gigabytes are completely justified for this instance. Another setting what we have is innodb buffer pool instances, and it will split buffer pool into multiple chunks to reduce contention on busy servers. So what is the benefit? It improves concurrency and scalability on multi-core CPUs. And usually there is some kind of rule of thumb or golden rule to follow, that you want at least one instance per 1 gigabyte of buffer pool memory size. So in our case we have 2 gigabyte, so we put 2. If you increase this in the future to 4, make sure to also increase this to 4. All right, let me change it back. Then we have innodb log file size, and this defines how large each redo log file is. Larger logs reduce flashing frequency and improve performance on heavy write workloads. And the write workloads are when you're adding new products, when you customer check-in, every single action basically is being stored and mapped in the database. So this is really also important. And the benefit, you will get better write throughput. And downside, longer recovery after a crash, And typical range is 256 megabyte to 1 gigabyte, depending on your database size. So yeah, I usually put 512 megabytes. And if I have really big e-commerce store, that requires more memory, and there are thousands of transactions every minute, I will of course increase the log file size. And then we have query cache tweaks, and those are only for MariaDB database specific. You cannot use those in MySQL. And yeah, those caches the result of identical select queries to serve them faster. And what's the benefit? Speeds up the repeated queries, most likely in the WordPress frontend, where you need to load WP admin, you need to load plugin settings, etc., etc., etc. There is also downside. So with many dynamic, non-repetitive queries, it can cause memory contention and reduce performance. So yeah, I recommend to keep it small, between 32 megabytes and 64 megabytes, and try to never exceed 128 megabytes. And you can change it basically here. Then we have a performance schema variable, and this basically disables the performance monitoring engine. And yeah, it frees up the memory and CPU overhead. So yeah, we don't basically need to have those there. And then we have the SQL mode, and this prevents MariaDB from automatically substituting a storage engine if the specified one is unavailable. So the benefit is it will ensure predictable and consistent behavior and standard practice for production databases. So yeah, there's nothing else we can talk about that. Then we have innodb log buffer size, and this defines how much memory is used to buffer log data before writing to a disk. So this is the standard operation how most of the databases are working. So it will basically store those in the buffer, and then it will dump it on the disk and write it actual tables to the database. So it reduces disk writes for frequent transaction, and good range is between 256, 512, or even 1 gigabyte. So larger helps heavy write workloads. So if you have seriously heavy write workloads on your application, feel free to increase it. And then we have innodb IO capacity. And yeah, those basically tells innodb how many IO operations per second can your storage handle. And benefit is it will help innodb schedule background tasks like flashing and merging efficiently. So a rule of thumb for HDDs, standard hard drive spinning hard drive with platters is around 2000, and for SSDs 2000, 6000. And for NVMe's you can go even up to 10k to 12k, but I use it to the 5000. So yeah. Then we have checksum algorithm CRC2, and this basically specifies the checksum algorithm for the data integrity. Benefit is CRC2 is faster and more modern than all the algorithms like innodb, and it is for modern hardware and MariaDB versions. Then we have innodb log of compressed pages off, and it will prevent login of compressed pages into the redo logs, and it will significantly reduces unnecessary IO load. And it is safe to disable unless you use heavy compression. And then we have innodb change buffering, and basically it will allow buffering of inserts, updates, and deletes in memory, and it will greatly improve performance during high write activity. And always keep it all unless you are using very fast NVMe storage. So yeah, in our case we can keep it on. And then we also have let me see what I did not covered. Yeah. And then we have skip name resolve. I think those are the enhanced default. So skip name resolve, it will disable DNS lookups for client connections. And by default, MariaDB tries to resolve each connection client's hostname via the DNS. It may sound harmless, but it can cause huge connection delays or even hangs, especially if your DNS is slow, misconfigured, or unreachable. And yeah, this is basically for if you are running uh, a database server on a remote machine, so you don't want to have those there. And then we have default authentication plugin, MySQL native password, and it sets the default authentication method for new users. So modern MariaDB MySQL version introduced newer authentication plugin like caching SHA-2 password, I think in MySQL 8, but not every application libraries or PHP extensions support them properly. So we set this to the native password, and that ensures the maximum compatibility across all the web applications, control panels, and CMS platforms. Yes, it is less secure than newer hashing methods, but it is still solid if paired with strong passwords and SSL connections, which we already have. And then we have skip the host cache. And purpose of skip the host cache, it will disable in-memory cache that store the host lookups and authentication results. So yeah, it will ensure immediate effect after changing user privileges or host access. It prevents unexpected access denied issues after updates, and it is useful in containerized or dynamic IP environments. And yeah, that's it for this database optimization. So as I mentioned, you can get all of those in nice copy paste in the premium channel on Webnestify Discord. So I'm just going to save it. Make sure to save when you edit your Maria database tweaks, and you also need to restart your database. All right, so now let's move how we can make our object cache Redis application more secure. Okay, and now let's jump straight into how we can optimize our Redis container in WordPress. So this will require more setup because it is we cannot set some global defaults, and it is based for each single website as container. So what we want to do, basically we can open any website, or you should open every website and set those things up. So when you go to the advanced menu, go to the developer tools, go to the Redis, and as you can see we already have Redis enabled, and here is the redis.conf. So we want to edit this configuration file, and the default value is to bind to our localhost, which is really great because sometimes I think on some providers the Redis is wide open to listen to any connection. It is not bind to our localhost, which makes Redis very unsecure. And if there is an CVE that can be exploited widely, you know, those servers can be taken over by those exploits. So always make sure the Redis is listening to the localhost. And how we can make Redis even more secure for the containers. So yeah, what we can do basically is just add, require pass, and then you generate your super strong secure password. So let's go to the Bitwarden, generate the passphrase, and generate the passphrase, which are secure. And I always recommend to use at least, at minimum, seriously at minimum, 32 characters with mixed symbols and numbers. And yeah, this is like the passphrases are always more secure than passwords. So yeah. So once you add that, what you make sure to save it, and it will also restart the PHP container. And when you go to your website, let me go here. Let's go to the home icon, log into WP admin. And you will need also to set this password in your plugin. So if you are using, Lightspeed cache, it's very simple and easy. You just go to Lightspeed cache, you go to cache menu, object cache, you turn it on, you select Redis, you change the port to 6379. And actually when we save the changes, we will see that the connection test, like we have here, will fail. So let's go and save changes. And as you can see, it fails. And the reason is we put a password for it. So here in the password menu, you just paste the password you set for your Redis, and you just click Save Changes. You refresh the page, and as you can see, the connection test passed. Also, what we can do, I think we can probably also remove this. Let's go to Save Changes, refresh the page. We can go here, and we can also set the password in WordPress config. So let's go to the file manager, public HTML, and let's open WP config. And what we can do, we can add another Redis thing. So let's just do it straight away here. And we paste our password here. But I'm not sure if that works. I'm testing it first time. So let's just see it. Let's click save. Let's click save. Close. Go back here and yeah, it looks like yeah, it passed. So let me go back. Try to uncomment that. Make sure I'm right. And yeah, actually it stores the entry in the database, so you don't need to put it all the time. So yeah, that's basically it. And yeah, there are many other tweaks that you can use for Redis, which we already have on the server side. So probably I can show you that. So let me pause it so I open a terminal. And yeah, so we are in the terminal, and what I'm going to do, I'm going to check the server configuration for the Redis, because what we've done before is the web application specific configuration. So I think the main Redis file is nano etc redis, and I think it is redis.conf, yes. And as you can see, again, we have the bind, which is binding to our local host. Then we have the protected mode. Yes, that means that is extra safety if misconfigured, like open binds, and it will block dangerous commands from untrusted clients. Port is standard 6379, and all other things I think are just fine. And what I would probably yeah change, for example, if your CPU is not powerful enough, I would change I would reduce actually I would disable the compression. So when we go here to Redis database compression, I just would say no if you have really tiny server, but on the most dedicated servers, I think the compression is completely fine. And yeah, there's nothing else that stands out. The defaults are actually good. So yeah, that's basically it. Control O, Control X to exit, and yeah, that's basically it. So we covered all the advanced optimizations that I recommend to use, but yeah. All right, everybody. So that's it for this advanced enhanced configuration. And as I was mentioning at the beginning, those are the default that I recommend to use on basically every setup. And as I was explaining, every single optimization that I've done, it also depends on the type of web applications you want to run or what type of server you want to deploy. So this is like the template, which you can also adjust to your specific needs. So yeah, and to get those tweaks in one nice document, so you can copy and paste those, you can hop to the Webnestify Discord, or if you don't prefer the Discord, I'm probably thinking about the different ways, because not everyone likes Discord, and also especially after the recent data breach. So I'm thinking about other ways how I can interact with you and for our supporters, and maybe we will completely disable the Webnestify channel YouTube membership, and maybe I will open some kind of community so we can keep in touch, we can post, and etc. etc. So yeah, let me know down in the comments below what you prefer, and yeah. So yeah, that's basically it, and I hope you enjoy it, and stay tuned for the next video. Take care and bye bye.